This is question number 20 from the June 2015 Geometry Regents exam. So in this diagram, we are told that the diameter AC is perpendicular to CD at point C. So we know we've got dealing with a right angle here. And we also know from the semicircle theorem, or the semicircle property, that the angle at B is 90 degrees. That's because it's an inscribed angle that is subtended by a semicircle. And similarly, the angle at E is also going to be 90 degrees for the same reason. It's an inscribed angle subtended by a semicircle. Based on that knowledge, we can say that statement number 2 is always going to be true, that ABC and ACD are equal because they're both 90 degrees. And option number 4 is also always going to be true. That one says that CBA, that's that blue angle there, is equal to angle AEC, the green one. Now let's take a look at statement number 3. That one says the angle BAC, that would be this red one here, is congruent to angle DCB, this angle here. Now that might look a little confusing and hard to show whether or not that's true, but check this out. So angle DCB, you could find by taking that 90-degree angle and subtracting, let's call this little angle X. This little small one here. Hopefully you can see what I'm drawing. Okay, and so that's that angle. And then take a look at the one over at A. Similarly, we can find it by taking 90 degrees, the angle at B, and subtracting angle X. Why? Well, because we know the three angles in a triangle add up to 180 degrees. So taking a look at this triangle here, we can find that angle by taking 90 and subtracting X. And that's because those two angles are complementary. They would together will have to add up to 90 degrees in order for the whole triangle to add up to 180 degrees. So I hope that makes sense. But essentially what I'm trying to say is that option number 3 is always going to be true because they're both 90 minus that X angle that I created. So statement number 1 is our answer. It's not always going to be true. All right, hope that was helpful, and thanks for visiting JD's Regents Preparation.